I've been asked to create a video about numbers 10 and 11 on the 2016-2017 systems test. I'm going to do right now one for number 10, and let's see if I have time to get to number 11 in the same video, or I may make another one. So in number 10, we have a situation where we've got a two-digit number, and the digits of that two-digit number add up to 11. Okay, so that's the first piece of information we have. I'm going to call the tens place digit x. I'm going to call the ones place digit is going to be y. So we know that the two digits add up to 11, so x plus y equals 11. And we also know that if we reverse the digits, the new number would be 45 larger than the original number. So we're going to have some sort of subtraction problem that equals 45. So basically, I'm going to express this in this way. I'm going to say the new number, this is not really y times x, the new number yx minus the old number xy, where x is in the tens place in the old number, and the new number y is now in the tens place. That difference equals 45. But now I need to actually express the two numbers. So since y is in the tens place in the new number, I'm going to say 10y plus x. And put parentheses around that. So we know that this is our new number. 10 times the tens place plus 1 times the ones place. I'll even put a 1 there to make that really clear. So then I'm going to have my old number, which that x digit for the tens place is really a 10 times x, and the y is in the ones place. So 1 times y, and that's going to equal 45. I'm going to do the subtraction. I can do it a couple ways. I'm going to do it this way. I'm going to drop the parentheses around the first two because 10y plus 1x, that's just addition, so I don't need to worry about changing direction. But now I've got this minus. That minus is really a minus 1. So that's like having a minus 1 here. So negative 1 times 10x is going to be negative 10x. And negative 1 times 1y is going to be negative 1y. And that equals 45. So I look through all of this. I've got these like terms, 10y and negative y. I've got 1x and negative 10x. So I'm going to end up with a 9y and a negative 9x. Because 10y minus 1y is 9y, and 1x minus 10x is negative 9x. And that equals 45. Now, my next step is to put these two systems together. Now, I have this problem where x and y are not in the same order, so I'm going to go ahead and reverse that order and make it y plus x equals 11. I've already want to remind myself to define x as the tens place and y as the ones place. But now I have these two equations, and I can start to work with them. I have two choices. I can multiply everything on this one by 9, or I could factor 9 out of everything here. I'm going to do that because I think that'll be easier. So I'm going to copy this down here, and put it here. If I factor 9 out of this, it's just y. If I factor 9 out of negative 9x, it's just x. If I factor 9 out of 45, it's just 5. Now, I have these two equations. Here, I'm just separating them so it's clear that that's what I'm working with. I have two ways I can do this. I can subtract and get rid of y, or I can add and get rid of x. I'll start by subtracting. If I subtract y minus y, I get nothing. X minus negative x is 2x. 11 minus 5 is 6. So x equals 3. Now if I do the other way around, and I add them, I'm going to get 2y equals 16. So y equals 8. So since my tens place is defined as x, my tens place is x and my ones place is y, my number is 38. I can test this out. My reverse of that number is 83, and 83 minus 38 is, okay, I borrow from the 8, that makes a 7, so this is 13 minus 8, so that's a 5, and 7 minus 3 is 4, and that's my difference, 45. That was the difference I said it would be. My answer is 38. I'm going to stop here, and then I'll do the video for number 11.